facility assigned us the first ever focus plant on production materials. So it's called fossil fuel to provide both energy and raw materials such as ethylene for the production of other substances. Alright, first of all, we have to understand the difference between alkane and alkene, because I know we have a lot of trouble with that. So alkanes are hydrocarbons with only single bonds, and the formula is CnH2n plus 2. And alkenes are hydrocarbons with one or more double bonds, and the formula is CnH2n. Alkanes are saturated, which means they have single carbon bonds, and alkenes are unsaturated, which means they have double carbon bonds.
So petroleum is a mixture of crude oil and natural gas. Mainly consists of alkanes and small quantities of other hydrocarbons, such as alkenes. Crude oil is separated into fractions using fractional distillation. Each fraction has a mixture of molecules that have a varied range of boiling points. Paraffins are present in all fractions. They are simply alkanes. Ethylene is a useful substance in petrochemical industry and is high in demand.
Okay, so this is how petrol is extracted from crude oil and stuff like that. So you got that, they put it into a fractional distillation column, and they do that fractional distillation thing, and they get all this products out of it. Another way to get ethylene is cracking. So cracking is the process of breaking large hydrocarbon molecules into small length chains using heat. This process can be categorized into two groups: thermal cracking and catalytic cracking. So thermal cracking is known as steam cracking, consists of one chain alkanes passing through pyrolysis coils at temperatures ranging from 750 to 900 degrees Celsius. The alkanes are decomposed completely into ethylene and other short chains. The use of steam allows easy flow of hydrocarbon gases, dilutes the mixture for smooth reactions, and removes carbon deposits in the pyrolysis tubes. Thermal cracking has three main steps: initiation, propagation, termination. And yeah, so catalytic cracking.
Catalytic cracking process is carried in a cat cracker. Long alkane molecules, such as C15 and C25, are broken into two molecules, one alkene and two alkanes. The catalysts used are zeolite crystals, aluminum silicate. The catalyst provides a high internal surface area through its cavities and channels. The reaction takes place at around 500 degrees Celsius, absence of air. This process uses less heat than thermal cracking, however cannot decompose large molecules completely into ethylene as efficient as thermal cracking.
Okay, so now this is the next dot point, so we have to talk about addition reactions, which will then go into addition polymerization. So addition reactions are reactions which ethylene can undergo. The double bonds of the ethylene are broken into two atoms from a diatomic molecule are broken, and two atoms from a diatomic molecule are added on. So then there's hydrogenation. So hydrogen reacts with ethylene to produce ethane. Hydration is when ethylene is reacted with water using dilute sulfuric acid as a catalyst to produce ethanol. Halogenation, reactive molecules from the halogen group can react with ethylene. And hydrohalogenation is when hydrogens, which is HCl and it's supposed to be HFI, and ethylene can react to form a haloethane.
Polymerization is a chemical reaction in which many identical small molecules combine to form one very large molecule. The small identical molecules are known as monomers, while the large molecule is called a polymer. Due to its double bond, ethylene is able to undergo polymerization. Ethylene, a monomer, forms the polymer polyethylene. In addition, polymerization reaction, no additional molecules, for example water, are produced. There is no gain or loss of atoms. The double bond simply opens and monomers attach.
Yeah, okay. So this is the two types of ways the two ways to get from like to produce LDPE and HDPE. So we have the three steps, which is initiation, propagation, termination. For both the polymerization with the initiator and the polymerization with the surface catalyst, which is the Zygonatta process. So in the initiator one, we have the initiator is heated to produce free radicals, which then free radicals combine with ethylene to form monomers. Free radicals combine with ethylene monomers. The propagation step is where ethylene radicals react with more ethylene monomers, creating a chain of increasing length. In termination, the process is stopped when two ends of the free radicals are joined together, thus creating a single long chain. The pressure and temperatures and mole mass is 100 to 300 MPa. Temperatures range from 300 degrees Celsius, and the mole mass is 1 million grams per mole. The result is low density polyethylene branched. They have a branched chain, scattered molecules. They have weak dispersion forces. They have low density, low melting point, and allows transparency of light. And then the uses are plastic bags, electrical insulation, glad wrap, and cling wrap. With the polymerization with the surface catalyst, a solution of ethylene gas is passed through a liquid solution of alkene containing minute amounts of titanium chloride and triethylaluminium chloride acting as catalysts. Ethylene free radicals react with more ethylene monomers, creating a chain of increasing length. Then in termination, the process is stopped when two ends of free radicals are joined together, creating a single long chain, which is the same as the one with the initiator. The pressure for it is 60 MPa, temperatures ranging around 60 degrees Celsius. Mole mass 3 million grams per mole. And the result is high density polyethylene, which has a linear chain, packed densely, strong dispersion forces, high density, high melting point, and due to crystalline regions, they scatter light. The uses are buckets, wheelie bins, household pipes, and plastic crates. Okay, so this is the next stop point after the production of HDPE and LDPE. So there's no title, but it is ethylene molecule with one of its hydrogen atoms substituted with a chlorine atom and forms so this is the production of this is polyvinyl chloride and stuff like that. So yeah, so that's what polyvinyl chloride looks like. Its uses related to properties. Garden hoses is unreactive, flexible and durable, and contains UV inhibitors. For piping and guttering, they're rigid and hard, as well as being unreactive, easily shaped by adding a plasticizer, as it decreases the dispersion forces. So yeah, next one is styrene. The systematic name is polyethylene. It is an ethylene molecule with one hydrogen atom replaced by a benzene ring, which forms polystyrene. So this is the meaning of polystyrene, how that's created. So one hydrogen atom is replaced by a benzene ring, which creates polystyrene. So this is a question from the HSC 2002. Yeah.
So the question is, explain why alkenes and the corresponding alkanes have similar physical properties but very different chemical properties. So there wasn't any marking guidelines. You just have to explain why they're different and why they're similar. So alkenes and alkanes, they're both going to have similar boiling points since they have a relatively similar carbon chain. However, they both have different uses, since ethene can be converted into a polymer, however ethane cannot.
Okay, so that's not a 3-mark answer, but like, yeah. And there's explained similarities of, okay, so is this the marking criteria?
That's all I call it.
Yeah, okay. Alright. So yeah, can anyone actually answer that question, like properly?
So it's okay.
I think Jeff wants to answer the question.